Sometimes I wonder if it's really possible to sleep for 100 years as Sleeping Beauty, or is gingerbread and cookies a proper material for a cottage? Or could Cinderella really run in her glass shoes? My name is Daria Cegiełka. I study physics, and today I would like us to zoom in on hair. I would tell you about my research, and I would like you to think if there could be any practical benefit from asking such childish and ridiculous questions as in the beginning. You know, when I was a little girl, my favorite princess was Rapunzel. Oh, it was Rapunzel here. Rapunzel was known for her beautiful and long hair, and I have always dreamed about having hair like her. But in that fairy tale, there is one quite tiny problem. It is not the bad witch. It is not the high tower that we are trapped in. The problem is rather serious. The issue is that a hair is a still tissue, and that means that it is not able to regenerate when we destroy it. And we can damage our hair on everyday basis. Sun, wind, or simple brushing, they are all factors that can affect our hair quite badly. And as you see, they are as common as inevitable. So as to avoid them, we should take our hair off, put it into a safety box, and wear only on special occasions. Quite uncomfortable, don't you think? That's why I've asked myself a question. Is it really possible to have such long and beautiful hair as Rapunzel? Well, I'm a scientist, so it's easy. There is a question, so brace yourself. The research is common. You may say that it's nothing special. As humanity, we studied already the structure of hair using scanning electron microscope. It's more or less like microscope you know from school. But instead of beam of light, we use a beam of electrons. But it has two disadvantages. Firstly, it is big and expensive. But secondly, the sample that we measure needs to be conductive. And hair in its nature is not. So how we can make such pictures? Well, we need to cover a hair with a thin conductive layer. But not only does it lengthen the procedure of sample preparation, but also it gives us a risk that we may miss something by covering it simply. That's why, like in every fairy tale, in my research, we need a hero, desperately. And our today's hero is called atomic force microscope. The heart of it is a cantilever with a sharp tip in the end, almost one atom. The cantilever approaches the surface, and it uses the atomic forces. Due to that forces, it deflects, and we can measure that deflection by really precise optical system. Then we scanned our surface point by point, and then we can reconstruct the topography of it. Quite simple. And that tool has three amazing features. First one is hidden here. As the name suggests, atomic force microscope uses atomic forces. And that forces does not depend if the atom is in metal or an insulator. So it's universal equipment, the first feature. Second one is hidden here. Atomic force microscope could work in two modes. The first is the contact mode, when the cantilever is in the direct contact with the sample, and it follows the changes in height. But we can also use the non-contact mode, when we drive the oscillations of the cantilever, and the frequency of such oscillation depends on the forces that cantilever feels. That means that we can image the surface without touching it. Why it's so important? It's really important when we have fragile biological samples, such as cells or a hair. And the third, last feature, which is quite amazing, is here. Can you see that? That is the simplest atomic force microscope I could ever work with. This wigwam is responsible for damping the external oscillations, and the microscope itself is hidden in that box, and it is so small. So the third feature is simplicity. Using such simple tool that you could pack to your car and go anywhere, you are able to image the surface in the micro scale. And so as to understand what micro really means, I would like to introduce you someone. Ladies and gentlemen, please let meet Stefan. Stefan is a cheerful polygon, and his height is A4 paper. If the distance from Warsaw to Krakow were a meter, a Stefan would be a micrometer. That means that with atomic force microscope, we cannot say that Stefan has sparkling eyes or cheerful smile, or he is blushing, but we can simply distinguish Stefan from the bottle standing here, from me and from all of you. For me, it's quite impressive. Now, we know our tool quite well. We know that it's simple, that it does not damage the samples, and that is universal. So now we are ready for our research itself. In the first part of my research, I have studied the influence of time on hair structure. And because for hair, time means distance, I have studied a 70 centimeter long hair. In fact, my hair. According to American Health Society, a hair grows on average 15 centimeters a year. That means that near the follicle, my hair are quite new, but in the end, they have almost 5 years. So I've done the measurements in different sections, what you can see here. At the beginning, a hair is really smooth, and hair scales lies really neatly. But after 3 years, only 3 years, the situation changes dramatically. The edge of hair scale is really rough, and after 5 years, in the last picture, you could see even that some scales are missing. We have cavities in our cuticle layer. So that part showed me that time affects our hair really badly. But another question is, can we do something? Can we help our hair to regenerate, for example, with special treatment? And does it really work? Well, we could try. Here I have studied the influence of hair conditioner on hair structure. In the top pictures you have the hair without the conditioner applied, and the bottom with conditioner applied. I would like to draw your attention on the cross sections. They are made all in the same scale. If you look closer, you will notice that the average step size in the top picture without the conditioner is about 0.5 micrometers, while in the bottom picture with a conditioner applied is about 0.4 micrometers. That is about 20% change. That suggests that conditioner is filling the gaps between the scales, and we can say that it rebuilds our hair somehow. So, I need to say that I had a great fun conducting such research. It was also a great challenge too. But is it really useful? Can we use that method and my research for something practical? Well, the first beneficial person or institution would be, of course, beauty industry, because they could use that method and all my research so as to test if their product works well in the micro scale. But please do not think that it's all about the beauty or girl things. A hair is the indicator of our health state. Some certain diseases, like diabetes or throat problems, affect our hair really badly in the microstructure. Maybe such research, such really simple method, could be used for diagnosis. But the truth is that we don't know. For me, that tool is so perfect, so extraordinary, that I strongly believe that everything depends only on our imagination and creativity, so as to invent all of these applications. I hope that after my presentation, not only do you know that having such long and beautiful hair as Rapunzel is not so simple, but also that you are convinced that even childish or ridiculous question may lead to really serious problems worth closer examining, really worth that. So please, don't be afraid to ask. Thank you.